Okay, hello everybody, we should be live. Let me know in the chat if you can see me and hear me or if any issues. I've got the chat over here, so hopefully we're live. Just wait a second. Perfect. Thanks, Ivy. Okay, hello everybody, good morning and welcome to your COMP1511 Lecture 2 for week 8. Clearly, I am not Jake, or I'm not Henry. I'm Sophia. I'm one of your course admins, and I'm going to be taking today's lecture. A little bit about me. I took this course in 2022 T1, and I've been tutoring it ever since, and I've been adminning for a year and a bit now, but I don't go to uni anymore. I've graduated, and I work as a software engineer at Atlassian. And yeah, I'm going to be taking your lecture today, so I'm really excited to, teach your lecture. I've got the chat over here, so please talk to me in the chat as we go along. Feel free to stop me at any point if you have any questions, queries, concerns, complaints, comments, anything like that. And let's get into it. So Today, we're going to be doing a few things. We're going to chat about multi-file projects, which for those of you who may have started assignment 2 would know that it's a pretty important part of your assignment. We'll do a little demo. We'll recap linked lists in the form of a Kahoot, of course. It's not a 1511 lecture without a Kahoot. And then we're going to do a larger linked list demo program, which is going to be like a 2-day linked list, and it's more going to simulate what your assignment 2 looks like. So once we do this lecture demo, hopefully you're in a really good place to get started with your assignment 2. And looking at the poll, a good amount of you have not started, so hopefully this lecture helps you get on track for doing that. So I've said the word assignment 2 a lot, so if you're not aware, assignment 2 has been released. You can find it on the homepage of the course website. There's an overview video that I strongly recommend you watch before you get started, and also make sure you have a read of everything on the spec and don't just jump straight into the stages. And then if you're still feeling like you need a little bit more revision, maybe heading into final exams or for assignment 2, we have our week 8 revision sessions happening this week. So we've got the first session happening this afternoon, and then the second session I believe is on Thursday. Don't quote me on that, but you can check it out on the discourse announcement and sign up to get tickets there. Okay, cool. Thanks for popping those in the chat, Bree. I guess let's get right into it with no delay, multi-file projects. So all of you hopefully would have finished your assignment 1 by now, and you would know that your files got really, really long, and that meant it was really hard to find your code and work through things, and everything just got a little bit messy. So we have this concept of multi-file projects, and big programs are often spread out over multiple files for a few different reasons, right? So the first one is to improve readability. So by reducing the length of our program, it's easier to navigate. The second is you can spread out your code by subject, having modularity, which means it's pretty easy to find like related things next to each other. And the final thing is that modules can be written and tested separately. So right now, this might seem like, well, why would I need to write things separately? But if we're making it a little more large scale, this can be really handy. Up until this point in the course, you've actually already been using multi-file systems, even though we've only been working in a single .c file. And this is because every single time you hash include, you're actually borrowing code from other files. So ctype.h, math.h, string.h, all of those libraries that you've been including when you need certain functions like string compare or is lower to upper, all that stuff. Those are actually you just borrowing code from other files. So we're going to learn today how to hash include our own libraries, which is going to allow us to maybe join projects together, allow us to work with other people a little bit more easily. Because if you can imagine that you and your 5 mates were working on the same project, trying to work in one single file, things could get pretty messy, right? And you'll have like conflicts on top of each other, and it's just not going to end well. So we can separate it into multiple files. And we're also going to be able to make our code even more reusable. So you've already been making your code reusable by implementing functions, but by putting things into multiple files, you can have like sets of what they're kind of called utility functions that you can import into a bunch of different projects and use when needed. Think about maybe your string library. How many times and how many different files have you included that in? So you can use maybe string compare or string copy. So we're going to be doing that exact same thing today with our own libraries. So let's dive a little bit deeper. So with multi-file projects, we have like 3 key parts to them. A multi-file project will always have multiple or 1 header files, and this is a .h file, similar to the ones you've already been using for the standard libraries. Then we'll have what's known as an implementation file. And this is a .c file, and it implements what is in the header file. We'll talk about this a little bit more in a second. And just something to note here is that every single header file must have a corresponding implementation file. So that's a 1-to-1 relationship. The final file that we have is our main.c file. And this one is really important because this is the entry point to our program, almost like the brain of our program, because this contains our main function, which, as you would know, is always what your code goes to run. And the aim here is to have as little code as possible in our main.c file and our main function, So majority of it is extracted away to our implementation files. So diving a little bit deeper into the header file contains a few things. The first things it contains is usually any function prototypes for any functions we're going to implement in the corresponding implementation file, comments to describe these functions. We love well-documented code. Any hash defines, enums, or struct definitions are all going to go in here. So hopefully you can gather that this file is basically going to show a programmer all they need to know about how to use the code. There's no running code. It's more just a definition file that gives the rundown of everything that's going to happen in the implementation file. So bringing us to the implementation file, this is where you're actually going to define your functions that you have written the prototypes for in your header file. This is where majority of your logic and code is going to live. And finally, the main.c is the entry point. This is going to contain your main function. It'll need to include any headers for any modules that you may be calling the functions of as well. So this is all very abstract. It's a programming course. So let's write some code. That's what we're here to do, right? So we're going to have three files. We're going to have math.c, math.h, and main.c. And math.h, we're going to define our prototypes. Math.c, we're going to actually implement those functions. And then in main.c, we're going to call the functions from that module. So while I'm flicking over to VS Code, if anyone has any very simple math functions that we want to implement, please pop them in the chat. I'm thinking like year 7, year 8 math. Keep it real simple because I don't know my math formulas. And we've just got a question. If you have a very large project, could you have multiple? Yes, you can have as many as you want. So similar to how when you're working in like assignment 1, you might have like string library, C-type library, and so on included. You can create your own modules as long as you have a corresponding header and implementation file for each one. So let me flick over to VS Code. Let me make this bigger. I'm sorry for the light mode. I know I'm gonna get bullied, but I like light mode. Keeps me awake. Okay, area of a rectangle. That formula I know, so we can do that. We can do area of a rectangle. Okay, so let's start off with a very simple main function, right? So let's hash include standard input output.h, and we'll just set up our boilerplate code for a main function in C. Area of a rectangle, that's like width times height, right? I haven't done math in a very long time, but I think that's right. So let's set up like two variables. So double width, and we'll set up a height, and if I could spell, that would really help. Let's take in that information from the user. Please enter a width and height for your rectangle. And then let's take in some information from the user. Oops. Sent lf. And let's go here, and that will be our width and our height. Cool. So we've got our data. Now we need to set up our function. So if we were doing this without multi-files, hopefully all of you familiar, we would add a function prototype up here and define it below the main function in this code. But instead, what we're going to do is we're actually going to define it here. So let's do like double, calculate the area of a rectangle. We'll pass it the width and we'll pass it the height. So we've just got our function prototype here, and we'll go, this function calculates the area of a rectangle. Pretty simple. And now we can go to our maths.c, and we're going to actually implement that function. So I might actually just grab the prototype so I don't have to declare it myself. And this should just be width times height, right? So we're just going to return width times height. So I've got this so far. Let's make it a bit bigger in case people can't see. what is the last thing I need to do if I want to use a function from a specific module? If anyone has any ideas. Yeah, we need to include it. We'll get to defines in a second, but yeah, we need a hash include. And I can see someone has used the little arrow things. So in our main.c, we can see that we use the arrows for C standard libraries. However, when we're working with our own custom libraries, we need to use the double quotes instead. So we'll do something like hash include, and then we'll do our own math.h. And this is so the compiler can know that this is its own module that the user has defined, not a C standard module. So now that I've included it here, we're using the function prototype in this file, which is why we need to include it. We're going to want to call the function in main. So we need to include it here also. And then we can do something like this, and we can actually call our function. So this will take the width and it'll take the height. And hopefully we should be able to print that. So we should go, the area of the rectangle is, so LF, pop that there, and this will just be result. Does this mean the header file has to be in the same directory as the main file you're calling? In the bounds of 1511, yes. However, there are things we can do, such as like make files where you can have things in different directories and pull them in as long as it's in one parent directory. Don't worry about that for now. You'll learn all about it in COMP1511. But for the most part, let's say it all has to be in the same directory for the purposes of 1511. So at this stage, yes. So we can see that in my maths directory, we have a main.c, a maths.c, and a maths.h. One thing that's special about multi-file projects is that we need to compile all of our C code together. So if we just take a look here, when we're compiling multi-file projects, we essentially need to list any .c file that we have in our project in that compilation command. So in the case of our example, we're going to have to compile math.c alongside the main.c. We don't add the header file because that doesn't need to be compiled. That's going to be referenced when we need to look at function prototypes or any hash defines or whatnot. And the program, when we run it, it's always going to enter the main.c, which is why we need to include it. So if we follow that here, we can do something like dcc main.c, maths.c, and then we're going to output that to maybe maths. Hopefully it compiles. Let's run that code. And let's enter, I don't know, 3 and 4. So we expect the area to be 12, which, happy days, basic maths, it works, which is awesome. Let's do maybe one more function, one with a constant, maybe area of a circle that has a constant in there, right? Because we're going to need the value of pi. Oh, you guys reading my mind. So let's do double calc area of a circle. We'll give it a radius. And if I want to put the hash define, am I going to put it in my math.h or my math.c file? Oh, wait a second for the chat. I think there's a delay. Are we going to put it in our .c? Yeah, we're going to put it in our .h because remember, any definitions are going to go in our .h files now. So we're going to hash define pi as 3.14159. I think that's the value of pi. And let's actually put a comment. So this function calculates the area of a circle. And while we're cooking in the chat, can someone remind me the formula for an area of a circle. I'm not saying I've forgotten, but maybe lightly. Pi r squared, perfect. So we might just put this into a result equals to, can I do squared in C? This doesn't really exist, right? So we need to do radius times our constant. And then we can return, nope, it's rough, my IntelliSense. There we go. We can return that. And basically when we try and run this function, the compiler would have read this maths.c, this maths.h module already. So it'll know that this define exists and it'll basically grab it and find and replace that value from the other file. And now we can call our function. So let's do double radius. Is it better to have function comments in the header file or implementation file? You should always have them in the header file because that's where all your documentation and definitions go. You can have comments like within your functions implementations if you wish, but you should put them in your header file. I do appreciate though that I think for assignment 2, we might have asked for it to be in the implementation. Just double check that. But generally standard is to have it in the .h. Let me know if that doesn't make sense. Cool, so we prompted the user. Let's scan in and go to radius. And then we're just gonna let our same variable result equal to calculate the area of a circle with our radius. And then we'll printf the area of the circle is %lf, and we can give it result. Just group these pieces of code together for clarity. Okay, let's try and compile this. Hopefully no issues. Okay. 3 and 4, that's good. And maybe 7. Cool. I don't know what 7 times 7 times 3.14159 is, but I'm going to assume that it's that. So, looks good to me. Does anybody have any questions on how we're using this multi-file system in this context? So remember all of our defines, documentations, and everything like that in the .h, function definitions in the .c, and minimum amount here in your main. Realistically, I could have taken like all of this logic and put it into this function, but just for example's sake, we'll keep it out here in main for now. But yeah, I'll just pause for a second and see if there's any questions or anything before we move on. Don't worry, this isn't the end of multi-files. Can you see my .h again? Of course you can. We'll be doing multi-files for the big linked list demo as well, so don't fear. This should also all be available on the course website at the normal spot. Perfect, thank you, Bree. Let's move on. It's Kahoot time, my favorite time of the tutorial. Okay, it's not a tutorial, it's a lecture, isn't it? Okay, if you have multiple .c files, do you need multiple .h? Yes, every .c should have a corresponding .h file. If your main file is acting like you haven't defined pi, maybe make sure you've included your module with your hash include. Okay, let's do this Kahoot. If there's any questions, the lecture moderators can handle them. Hopefully you can hear the Kahoot music. Let me know if you can't, because that's important. Wait a couple more minutes. Okay, 1 more minute. Okay, I think it's slowing down. So, oh, one person sneaked in. Let's do it. Awesome. Great. So these, yeah, they're all very similar. The answer, a node contains data and a pointer to the next node, is correct. It can contain only a pointer to a next node, but linked lists usually have some data. And I guess like it can have a pointer to the previous, but that's a little complicated. But it must always have a pointer to the next node. We can have doubly linked list, but we won't get into that in this course. And a node contains only data. Well, if it contains data and we have a bunch of nodes everywhere, without that next pointer, we're never going to be able to join them together. Okay, moving on. I'll stop yapping. Awesome. Amazing, Toucan. Doing amazing. Okay, oofed. That was a little bit brutal for y'all. But yeah, we'll talk a little bit more about this when we do our lecture program. We'll do an insert at head operation. But basically, we need to create the node, set some data for the node, point where the node's going to go to, and then update the head. I feel like people would have got red and blue switched up. We'll demo that a little bit later and just discuss what happens if we have different orderings in our steps here and the issues that can arise. But yeah, we'll get into it a little bit later. Amazing Toucan, still on top. Okay, cool. Good chunk of you got that. Again, we'll talk about this a little bit more in a lecture program when we do it. But yeah, just a bit of revision for now. So we'll just keep moving for now. Amazing toucan, still on top. Good work. Cool. Looks like majority of you got that. Great work. Yeah, if we're working right at the head of our list, it's the first node, so we don't need to keep looking. But yeah, moving on. Oof, amazing toucan, took a hit. Sneaky, welcome to the top of the board. Cool. Yes, we've already only learnt linked lists with a next pointer. We have not learnt about doubly linked lists, and we likely will not learn about them because they're not content in this course. But 2521, look forward to it. Sneaky, still on top. Awesome. Okay, good chunk of you. Yeah, we only need to call malloc if we're creating a new node, because remember, malloc is memory allocation, and we only need to allocate new memory when we're creating a new node. If we're just traversing, we're just really working with pointers to existing nodes. Sneaky, still on top. Awesome. Yeah, we only use free when we want to free up some memory, which we only want to do when we're deleting a node and removing it from the list. Oh, Updog is getting up there. Linked lists require contiguous memory allocation. No. So contiguous memory allocation, remember that's like all in one block and that's an array. We need to be like in a sequential block and we can go through and everything's next to each other. With linked list, the whole idea is that we malloc little pieces of memory all around the heap and then we can like link them together and their memory addresses. Ooh. Oh, damn. Damn, y'all. Damn. Okay, let's take a look. Let's pause here. So what will the function return for the list 3, 5, 6, 7, 8, right? So this is a traversal of a list, and we're stopping at while current next equals to null. So if we take a look, I'm not sure if you can kind of see here. So 3 is the head of our list. And at this point, I is still 0. And then we check our while loop condition. So is current next null? At this point, no, it's not, because our next node has the value 5. So I iterates and current equals to current next. And then we check the node with value 5. Does current next equal to null? No, it's 6. So we iterate I, current equals to current next. And then we have 6 and we check if current next does not equal to null, which it does not, it equals to 7. So we do I++, current equals to current next. And then we check the value of the next node. Is current next null? No. Current next has the value 8. So we iterate I, current equals to current next. And at this point, we're at the node with value 8, but current next is null. So we're at the tail of our list. So we exit the while loop and we return the value of I, which in this case is 4. Yeah? This one was a little bit tricky, but yeah. If you have any questions, let me know. Oh, 30 seconds, yeah. Yeah, look, sorry. As you guys said before, I was giving you too long to think, so I was just warming you up. And at the end, we got to shake up the leaderboard a bit. Okay, but that one did nothing. Okay. Cool. Okay. So you guys are very close. And you guys are correct, actually. It will be a runtime error because if we have an empty linked list, so our head pointer just points to null, we'll initialize I to 0, but then we're trying to access current next, but current does not have a next pointer because it's not of type struct node, it's just null. So we are just going to hit a runtime error. This is when, if we're doing a while loop with current next, we're always going to need to check if current is null, which is one of our linked list common edge cases that we need to consider. In this case, we've forgotten to do that, which is why we get the runtime error. And I think we're up to the final question. Oof. I know the up dog joke from yesterday's lecture, but I'm not going to try. Henry's a lot more funny than me. So I'm just going to click next. Okay, brutal. I feel like I didn't give you enough time. That's my bad. But if you have a look, we have the list 3, 4, 5, 6. We initialize current to point to the first node in the list, which is 3. And we're checking while current next does not equal to null, we're moving it along. So when we're pointing at the node with value 3, is current next null? No, it's the value 4. So we move current along to point to the node with value 4. Then we check, is current next null? No, the next node has a value of 5. So current now will point to that node. Then we check, is current next null? No, it's the node with value 6. So we move, is it current next? Oh, it is current next. Sorry, my camera's in the middle of my screen, so I can't see my screen very well. Sorry. 3, we check current next, which is the node at value 5. So we move it to 4. 4, we check next, which in this case is the node with value 6. So that exists. We move it along to 5. We check current next, which now is the value of null because we follow next to 6 and then next again to the null. So we exit the while loop. We let boo equal to current next, which is the node with value 6. So current points to 5 and boo points to 6. And then we let current next equal to null. So 5's next pointer is just going to be null. And then we free boo. So our list is going to be 3, 4, 5. We'll talk more about deletions at the tail in the lecture program, so don't stress too much. Last question. Cool. Wow. Great work, everybody. So yeah, we have this function. The precondition is that head is a pointer for a linked list. So that's what is happening before we enter the function. And then the post condition, so once the function is run, the function has done some manipulation to the linked list, and the list might now have a new head node. So if we're updating a linked list, we're probably going to return the pointer to the new node in the list, which will be of type struct node, like you guys got. Look at the podium. Good work, Philip. Sneaky. And amazing toucan back on top at the end. Really good work, everybody, and kudos to Updog and Alien for also making the podium. If this was you, feel free to ask Jake or Henry next week for a prize. I'll see if I can send them some, but unfortunately it's online. So you can just get a special kudos from me and just know that you got a congratulations. Yeah. Okay. That's enough of the Kahoot music for a very long time for me. Okay. Let's introduce the concepts for our lecture program that we're going to work on, just so you guys have like 10 minutes to think about it over the break, and then we'll take a break and then we'll get cooking on it. So we're going to, after the break, we're going to be doing a linked list demo program, and we're going to be managing like a simple Spotify simulator. So we're going to have like some Spotify that's going to have a linked list of playlists, and then each playlist is going to have a list of songs within it. So this is a 2D linked list, which is a little bit further than what we've done so far in the course. It's the same thinking as like a 2D array, right? So when you guys first learnt arrays, you learnt 1D arrays, and then you learnt like an array can contain an array within it. This is the exact same thing. You've learnt 1D linked lists, and we're just going to take that a little step further to make them 2D, where a list can contain a head pointer to another list within it. So yeah, we're going to be working on Spotify.c, Spotify.h, and main.c. And these are some ideas for some tasks we're going to do, like initializing, adding and removing playlists, songs, calculating the duration, printing everything, deleting things, and maybe we have time like moving songs to the top of a playlist or merging playlists and whatnot. And this is a very close simulation to your assignment 2 stage 1. Very similar types of functions and very similar data structure with the 2D linked list. So we'll just have a little look at this. This is what the structure is going to look like. So up until this point in the course, you'd be used to having like a head pointer that could be in a struct, and that points to a single linked list, right? In this case, we're going to have a struct Spotify that contains a pointer to a list of playlists, which is the orange here. And each playlist is going to contain a name, a number of songs, a pointer to the first song in that playlist, and a next pointer, which is a pointer to the next playlist in Spotify. And then if we take a look at our songs linked list for a playlist, each song is going to be of type struct song, where it's going to have a name, a genre, an artist, and a duration in seconds. And then a pointer to the next song in the playlist. Yeah? So we have like this linked list and another linked list. So it's a doubly linked list. Sorry, not doubly. It's a 2D linked list. I should say that correct terminology for this course to not confuse you. And yeah, our last song in the list for our playlist will point to null, and the last playlist in Spotify will point to null. So I'm gonna leave you to think about this. There's also the starter code that we've already pushed to the course website. So we'll just have a quick look at what's going on, and then we'll leave it for the lecture break. So we'll look at the .h because that usually tells us what's going on. So we have the max length for a name. We have our genres. So in this Spotify instance, you can only have pop, K-pop, hip-hop, or indie music. Sorry if your favorite genre is not here. Our struct Spotify just contains a pointer to a playlist, the first playlist in our Spotify. Looking at struct playlist, it contains a name of the playlist, which is a string, a count of the number of songs in the playlist, a pointer to the first song in that specific playlist, and a pointer to the next playlist in the Spotify system. A little bit deeper, struct song, we have a name that's a string for the song. We have an enum genre that's called genre. We have a string that's the artist of the song. We have the duration in seconds and a pointer to the next song in the playlist. So we're going to be implementing these functions. I've provided a few function stubs, but we are going to have to define a fair few ourselves. So we're going to initialize, add a playlist, create a song, add a song, print everything, remove a song, delete an entire playlist, delete our entire Spotify. Maybe we might print songs of a specific genre, merge some playlists, so on and so forth. If you guys have suggestions, we can do other things as well. And then we have a few provided functions, similar to like how we've got a few provided functions in assignment 2. The first one is print song, which is going to print out the details of a specific song. So you just give it a pointer to a struct song, and it'll print it for you in a specific format. We have genre to string, which is going to convert an enum genre to its string version, and it's going to return a pointer to the string. And the final thing is print playlist duration. I mostly just provided this because I didn't want to do the math in front of you for like divisions and modulus, but it just converts seconds to a total duration. And we can see these here. It's just printing things in format really. And then all of these are what we call function stubs. So we've kind of set it up, but we have not implemented them yet. So we're gonna have to like delete these and actually write the implementation. This is very similar to how the starter code is provided for assignment 2. And finally in main.c, I've just set up a few function calls, just so there's stuff there to save us having to type it all ourselves. But we can see I'm just creating a few playlists, adding some songs to each playlist, printing it, removing some, printing it, printing a couple things. So as we implement these, we can change this main, but this is just for testing. It's not really gonna do too much for us. So that's the multi-file system that we're going to be working with after the break. I think it's probably a good time to take a break. It's exactly 11:50, so let's take 10 minutes. Do what you gotta do. All of this is available on the course website, so if you wanted to take a look at the starter code, have a bit more of a read, I'll keep my eye on the chat. But yeah, we'll move into the mid-lecture break. Okay, sorry to break the lovely lo-fi music, but we are back and we're going to get into it, and we're going to be making a bit of a bigger lecture program. Hopefully you guys can see me and hear me. I see people saying welcome back. My preview hasn't updated, but I'm going to assume you can see me and hear me. Let me know if you can't. Audio, video got all good. Perfect. Thank you, Bree. Appreciate that. Oh, it's just updated now. Awesome. Okay. Yeah. So hopefully you had some time to have a little think about the structs and everything we're going to be doing. Would I recommend coding along or watching closely? We're going to do this a little bit collaboratively. So I'm going to be asking you questions and we're going to be working together to build this. So if you want to just watch closely, ask questions and engage as we're doing it, go for it. But if you learn by doing, feel free to code it up yourself and follow along, whatever works for you, really. Yeah, let's go. So let me just change directories. cs.spotify.h. What's the first thing we got to do? We're going to be working on initializing Spotify. So we're going to create and initialize a new Spotify system. So if we're creating a new node, does anyone have any ideas what I'm going to need to be doing in this function? malloc, that's exactly right. So we're going to need to malloc a new struct Spotify, and we're going to initialize all of the fields in the struct to some reasonable value. So in this case, we only have a list of playlists. And if we're creating our Spotify for the first time, we don't really have any playlists. So what should we set this field to at this point? If we're pointing to nothingness. Null, exactly. So let's go ahead and do that, right? So we can do struct Spotify, new Spotify, equals to malloc, and we want to malloc enough space for the struct Spotify. So we're going to do malloc size of struct Spotify, and then we're going to need to assign all the fields within this struct. So we'll go new Spotify, and we're going to use our stab notation, which hopefully from yesterday's lecture you remember is the same as dereferencing this pointer, so new Spotify, and then accessing like whatever struct field within it, right? So we use this notation and we'll go Spotify, and we're gonna let that equal to null. And then we can just go ahead and return the pointer to this new Spotify system that we have created. Oh, sorry, yes, stab is the arrow. Thank you, Bree. I'm not sure what Jake teaches it or Henry as, that's just how I know it. And what I might do is I'm just going to comment out everything that we haven't quite implemented yet. I'll just leave a few of those add playlists for now, just so we can check that this doesn't throw any errors. So if I want to compile this multi-file system, we can see I've already included my Spotify module in here, and I've included it here because that's where I'm calling functions that have their function prototype in this module. How would I compile this multi-file system? What do I need to type into my terminal? Obviously DCC, but beyond that. Any ideas? All the projects you use. Yeah, we need to put all the C files for everything, and always our main.c, right? So we need main.c, spotify.c, and then we need to put what we want to put it to. Yeah, all the C files. Great. So we compile that. Oops. Well, it's not new Spotify stab Spotify. It's new Spotify stab playlist. That's on me. Recompile. There we go. Let's run it. And we expect nothing to happen, right? We haven't added a printf in here saying we've created it successfully. All we're doing is calling that function and then adding some playlists to it. So we're just gonna assume it's happy days for now. Does anyone have any questions about initialize Spotify? I think the lecture mods should be able to help you. We might keep moving. So we're gonna move on to add playlist. So if we're adding playlists, let's do it adding at the head. So I'm just gonna pull over to a whiteboard just so we can visualize what we wanna do. And then we'll translate those requirements into code. So we have this like struct Spotify. And this contains a pointer to a list of playlists. And right now, this points to null. So if I want to create and insert new playlists at the head of my list of playlists, does anyone have any ideas what I'm gonna need to do to make this happen? Or some steps or any keywords related to what I'm gonna need to do? I'm not sure how big the lag is. Create a new playlist with malloc. Yeah. So we're going to be creating like this new playlist. We'll need to like assign all the fields within it. That's all well and good. And then we're going to need to insert it. So we're going to be doing a insert at head operation. So in the current state, when there's no playlists in the Spotify system yet, all we're going to be doing is updating what playlists points to point to new playlist, right? So that's the first case when we have an empty list. The next case is if I come along and I create another new playlist, call that function again, new playlist 2, that's got some values or whatever in it. And now I want to insert this at the head again. If I just go ahead and do what I did last time and update this pointer to just point to the new node that I create, like so, we've got a little bit of an issue here, right? Because what Spotify playlists used to point to, this node up here, and maybe any following playlists that it has, they are all going to get lost, right? This is some random chunk in memory, and I've now completely lost this playlist, which is not good. So what we need to do instead is before we update this pointer, just reset it back to the state, we need to make new playlist next point to the current list in our Spotify. So new playlist next is going to point to the current lists of playlists, which is whatever Spotify playlists point to. And then once we've made that connection, we can update Spotify playlists to point to the newly created playlist that we want to insert at the head of our linked list. I'll just pause for a second so everyone can think about that logic. Okay, so hopefully it makes sense. And we're going to translate this to code, right? So we'll handle the case when we have an empty list first, and then we'll worry about the secondary case. So, like we said, there's a couple steps of what we need to do. So the first thing is we need to create the new playlist with malloc, like someone suggested in the chat. The second thing is the case when we want to insert when there's no playlists in Spotify. And then the third thing we're going to do is insert when, there are existing playlists in Spotify. Yeah? So those are like the 3 steps / cases. Does this mean that the playlist list will ever point to null? It'll only point to null when we have nothing in the list. Cool, thanks Brie. So let's create a new playlist with malloc. So it'll be something like struct playlist, new playlist equals to malloc size of struct playlist. And we're going to need to assign all of the struct fields in our struct to some reasonable value. So we can see we've got a name, the number of songs, and a pointer to a list of songs, and a pointer to the next playlist. We've been given a name, so we're going to need to use some special string function to do this, because I can't really just go ahead and do this, right? I can't just let that equal to the name that's passed in. If I tried to do that, like even if I tried to compile it right now, our compiler is complaining because we can't assign an array, which I guess is just a string in this case. It's saying to use a loop to do it individually, but with strings, we have a special function called string copy that we can use that takes a destination, perfect in the chat, followed by a source. And this is going to allow us to copy whatever this variable contains into this one here. So we're copying that in. We can do new playlist, I think it's called num songs. And we're gonna let that equal to 0 because we have no songs in our playlist. Is that what the field is? Perfect. And then we have new playlist songs. And if we have no songs to point to yet, we're just going to let that equal to null. And as some initial value, we're going to let new playlist next equal to null. So that's the next playlist in the list, which we're just going to set it to null for now. And then we'll figure out if there's any existing ones when we insert it. So insert when there's no playlists in Spotify. So that means we want to insert when this here points to null. So not this case right now. And if we know that when there's no playlists, Spotify stab playlist equals to null, we can just check for that in code, right? So we can go if Spotify playlists equals to null, this means there's no playlists in Spotify yet. So we can just let Spotify playlists point to our new playlist. And we don't care what happens after that. We've done what we need to do, so we can just return out of this function. So this will handle the very first case, like this one here, where we're adding the very first playlist. But now when I go to add these other ones, there's already one node in the linked list. So we need to account for that and make sure we don't lose them like we did with our diagram. So we're going to insert when there's no existing ones. So we're going to do new playlist next is going to equal to the currently existing list, right? Because we're inserting at the head here. And then we can go Spotify playlists is going to equal to new playlist. So what we've done here is we've done that connection we were talking about last time. So I've created my new node, new 3, whatever. It's just going to start by pointing to null. Then we're updating our new node to point to whatever the current list of playlists is. So instead of pointing to null, we're going to point to the same thing that the black pointer does to. And then we can update our head pointer for our list of playlists to point to this new node. Yeah? So that is essentially what we've done here in this code. So we're checking if the list is empty. Otherwise, we're just doing this normal insertion. So if I was to compile it and run it, we get nothing printing, we get no issues, which is good. But obviously we're not really seeing if our code is quite working what we want yet. So it might be good just to implement our print Spotify function, just so we can actually traverse our list and check things are being added. Because right now we have no way to really visualize our code. So we'll implement that and then we'll double check that our logic for add playlist works. So we're gonna implement print Spotify. And with print Spotify, obviously we're gonna wanna print every song for every playlist in the Spotify system, but we haven't concerned ourselves with the doubly linked list yet. So we're just gonna worry about printing all the playlists in a Spotify system for now, and then we'll go back and edit it when we have more. So if I want to print every single node in my list, which means I want to print this one, and then I want to go through and print this one, and then I want to go through and print this one, I'm going to need to traverse my list. And what are we going to need to traverse our list in this case? Any ideas? A current? And what's going to be the type of our current pointer? Yeah, we're also going to need a while loop. Yeah, what's going to be the type of the current, or maybe the condition of the while loop? If anyone's got any ideas? Struct node, kind of, but do we have a node in this context? Yeah, so our node in this context, what you're familiar with, is a type playlist, right? So we're going to go struct playlist current is going to equal to Spotify playlists, yeah? Because we can see here that in Spotify, it's of type struct playlist, and we want to print every playlist. So we've got that, and then like suggested, we're going to be doing a while loop. So we'll be doing something like, while current does not equal to null. Now in this course, you'd be seeing a lot of like while current next does not equal to null, or while current does not equal to null. This can be a little bit confusing. How you know which one to use is, do you want to stop once you've looked at every single node in your list, or do you want to stop pointing to the last node in your list? So if you stop at current next equals to null, you're going to be stopping while current points literally at this node, right? The last one in your list. Whereas if you go to current equal to null, you're going to go past this node and you're going to have looked at every single node in the list. So in the case of printing, we want to print every single node, which is why we have the condition while current does not equal to null. And while current does not equal to null, let's printf the playlist name. Let me grab an emoji. And let's go %s, just make it cute, because, oops, why not? Just gonna do that, and we're gonna give it, it's actually called current, and we're gonna give it current's name, and we'll just worry about that for now. We won't worry about printing the songs or anything else. We'll just keep it real simple. And to traverse our list, obviously we go current equals to current, next. You can use %s to print strings, just don't scan them. Cool, and now we can return. And this should work. If it doesn't, that'll be really awkward for me. Cool, it did work. So we can see it printed Chill Vibes, K-pop hits, and COMP1511 1911's favorites. And if we have a look at the code, we're inserting favorites, followed by K-pop hits, followed by Chill Vibes. And because we're inserting at the head, we insert COMP1511 favorites, and then we put K-pop hits on top of it, and then Chill Vibes on top of it. Does anybody need me to diagram that, or are we all good? I think we might be all good. I'll just pause for a second. Cool, I'm gonna take one all good as everyone's all good. I'm gonna roll with that. Okay. Poll. Let's just keep moving. We'll do insert at the tail because that encompasses head. And once we add songs, we might do a poll. Thanks, Brie. Okay. Songs. So this is where things are going to get a little bit more complicated. Let's fix up this diagram really quick to actually look like what we've got at a very base level. And then we'll talk about how we're going to add songs and introduce our like 2D linked list structure. So here, this is our songs pointer right now, and it points to null. And this is called, what was the order? Chill Vibes. I'm just gonna put chill. And then the next one in the list, you guys can see it horizontally, can't you? Okay. The next one in the list is our K-pop playlist. And its next pointer is there, and its songs is pointing to null. And then finally, we have one more, which is our favorites playlist. Its next pointer points to null, and its songs pointer points to null. Obviously, these have like names and counts, but I'm just simplifying the diagram for now. So given we've got this structure, we want to go ahead and add songs to each playlist. And we're going to insert them at the tail of the list of songs for a playlist. And just looking at the add song, we're given a playlist name, and then we assign all the fields. So hopefully you can agree with me that the first thing we're going to want to do is create our song node. It's going to be of type struct song. We're going to then assign all its fields. So something like its genre, its name, all that stuff. We're going to let its next pointer point to null. And then we're going to need to insert it to a specific playlist. So in this case, we've not been given the specific node. We've instead been given the name of the playlist that we want to insert it to. So we're going to have to find that node in the list. So we'll just keep that in mind. And once we've found the node in the list, we're going to have to update its songs pointer to point to that song. So say, for example, I want to insert into my favorites playlist, and I've got this new song. I'm going to have to traverse this list here to find which playlist has the name corresponding to the one I want to insert to. Once I find that, we're then going to be updating that playlist's songs pointer to append our new song to the tail of the list. When we're doing insertions at tail, there's a couple things we need to consider, right? So there's this case right now when the list is empty. So I'm actually just going to move this over so it's close to it. There we go. So we have the case right now when the list is empty, which means we can just directly update this pointer to point here. We then have the situation, say when I have another song that I create that's new, and it's going to got some things and it's going to point to null, and I want to insert this at the tail of my favorites playlist, meaning that I'm going to have to follow this chain along, following any nodes that may exist in that list, to then update the last node in that list's pointer to point to my new song. Because the goal here is to update this pointer to point here. So I've now got this like little linked list structure. That's the general gist of what we want to do. I do appreciate there's a few moving parts here, but we can break it down and get through it, right? So the first thing we want to do is we want to create our new song. The second thing we're going to want to do is find which playlist to insert it at. And the final third thing is we're going to want to insert the node, and we just want to factor in the consideration of, is our list empty or not? Yeah? So let's just work through this list step by step and take it as we go. So the first thing, creating a new song. I've luckily prepared earlier a function that's going to do that for us. So if we're going to be creating a new song, hopefully you can agree with me that last time, similar to last time, we're just going to need to malloc some space for that struct. So it'll be malloc size of struct song. Then we're going to go ahead and update all of the fields in our struct song, which we can see a struct song has a name, genre, artist, duration, and a next pointer. So we can, similar to last time, string copy, new song name, and we're going to give it the name that was passed into the function. We can then go new song genre is going to equal to the genre that we pass in. New song, what have we got? Duration is going to equal to the duration that we pass in. And finally, we've got the artist, which is also a string. So I'm just going to put the two string copies together. So new song artist, and we're going to pass in the artist. Now that we've done this, we're going to have it point, new song next is going to equal to null. Because right now we have an isolated node that we haven't inserted into a list yet, so we don't know what the next point is going to be. So we're just going to let it be null as a placeholder. And then we can just return this new song that we've got. Yeah? So now in our add song function, we can do struct song, new song. So we're going to create a pointer that's going to point to the memory address malloced in our create song function. So we're going to go here and create song needs the playlist. Needs the playlist name. No, it doesn't. It needs its own name. Sorry. It needs the genre. It needs the artist, and it needs the duration. Yeah. So now that we've got this song, we need to figure out where it needs to go. And like I mentioned before, we've just been given a playlist name, not a pointer to the actual node. So we're going to need to find the playlist in the Spotify system. So let's make a function that's going to return a pointer to the node that we want to insert at. So it's going to be struct playlist, find playlist. We're going to give it a playlist name, so the one we want to find, and we're going to give it the Spotify system. So struct Spotify. And like suggested in the chat, we're exactly going to use string compare to find it. We've got the function here, need to pop it in here. So we have our function prototype, finds a playlist in the Spotify system. Cool. And we're going to implement it. So we're going to want to traverse our list and use string compare to find the node in the list. So let's create a current pointer. So struct playlist current is going to equal the first playlist in our lists. And let's go, while current does not equal to null, we want to check if we're pointing to the node that we want, right? So what we're doing is we've got a, let me actually grab a diagram here. So we're setting up a current pointer that's going to point here. And what we're going to be doing is we're going to be moving this pointer along, checking each playlist until we find one, checking each one until we find one that's name matches what we want, yeah? So like suggested in the chat, we can do if string compare between current name and the playlist name. I believe when they're equivalent, it's 0 with string comparency. If we found the one that we want to return that node. Otherwise, we just want to keep looking. So current equals to current next. And if we reach the end of our function and we have not returned a matching node, that means that the playlist was not found in the system. So we can pop that there. And now we can call the function. So struct playlist is going to be find playlist, and we're going to give it the playlist name and the Spotify system. I'm going to pause for a second to appreciate I've been going a little bit fast. Just looking at this, is there anything I'm missing? Am I going to be able to call this function right now from add song? Or am I going to run into some issues? Line 49 has double semicolon. That's not the issue I was thinking of, but it is going to be a issue. Do I have my Spotify system within the scope of my add song function? Spoiler alert, if I'm asking, the answer is probably going to be no. Yeah, I kind of forgot something. People don't really know what. The problem is that I'm using Spotify in the scope of this function, but I haven't passed it in as a parameter. So we're going to need to add it. So struct Spotify, which means I now need to update my function prototype in add song. And I'm going to need to update all of my function calls. I will also uncomment these, but I'm going to need to update every single one to include the Spotify system. Great. So now that I have included it, we can actually call find playlist. And now we're at the point in our diagram, I guess, if I just run it all back for a second, we're going to have a playlist pointer that points to where I want to insert. We've also now got a new node that's going to be our new song that points to null. And we want to essentially make this, instead of pointing to null, we want to have it point to our new song. Yeah? So let's insert it into our list. And we're going to be inserting at the tail. So we want to first check, is there any songs currently in the playlist? Because if not, we're just going to make playlist songs point to our new song. Otherwise, we're going to need to traverse, just like our consideration here. So we can do something like if playlist songs equals to null, we're just going to let playlist songs equal to new song. We might want to print something to let the user know percent %s added to %s, and we'll just print out the names, right? So we'll do new song name, and we can also do playlist name. Yeah, so that'll handle if the list is empty. If the list is not empty, we're going to do an insertion at tail function. So we're going to need to traverse the list to find the last song in the list and update the pointer. So if I've got this list and I now come along and I create another song called song 2, that's going to point to null, and I'm adding it to the same favorites playlist, I'm going to need to find whatever's in this list. In this case, it's just this node, and we want to update its next pointer to instead point to this new song that we have created. So let's find the last node in my list. Exactly as in the chat, read the mind of the question I was about to ask is what while loop condition we need, and we need current next does not equal to null because we want to stop at the last node. We don't want to go past it. So let's set up a struct song current song is going to equal to the first song in our playlist. And then like suggested in the chat, we're going to go while current song next does not equal to null. Let's keep moving along in our list, right? So current song, equals to current song next. And then finally, we're just going to let current song next equal to new song and add it to the tail. And then we can probably print and return. And I forgot to put my return here. I could like put all of this in an else and that would also work, but I can just return early from my function. So this is traversing to find the last node in the list and then inserting the new node. Cool. Let's give it a crack and see if it works. Awesome. So we can see they added, but we don't really know because we haven't printed them in the list. So let's go back and modify our print list function or print Spotify function, which now for every playlist to print the songs. So I'm just going to actually update this. So instead of just being current, just to be a little bit more descriptive, to be current playlist. And now for each playlist, not only do we want to print the playlist name, before we move on to the next one, we want to follow the chain down and print all the songs in the playlist. So hopefully you guys can agree with me that we're going to be doing something along the lines of struct song, current song. Cool. Struct song, current song equals to current playlist songs. And then we're going to have another while loop in there, right? So while current song does not equal to null, we want to print each song. And lucky for us, we've been given a print song function that takes a pointer to a song. And then we just want to do this for every song in the playlist. Yeah? So we'll print the playlist name, get the first song in the playlist, print all of them, and then move along to the next playlist in our Spotify system. So now let's compile and run this. And there we go. We can see that we've got Chill Vibes, there's nothing in there, K-pop hits, and COMP1511 favorites has a couple of songs. Let's uncomment out adding songs to all our other playlists. And this time we expect songs to be printed after every single one. Oops. I think I forgot to pass my Spotify into all of these. Let's go. Cool, that was it. Awesome. So we can see that all of our songs are getting added to our playlist, and when we print our Spotify system, all of our songs are getting added in the order. So we can see we added Touch first, so that's the first song. Miss Jackson second, so that's inserted at the tail. Love Story, again at the tail, and as requested in the chat, Golden, and that's now been added to the tail of COMP1511 favorites. And then we add Dynamite to K-pop hits, so that's added. Pink Venom, Touch gets added there also, and then the same for Chill Vibes. Could we get a poll just to check that everyone's feeling all right about inserting at the tail and inserting at the head of linked lists? And also, I guess, traversing, just a general vibe check of how we're going. Thank you, Bree. Appreciate it. Appreciate it a lot. I'll just wait like a couple seconds for that to come through before we move on to removing stuff. Thank you, Bree. Yeah, we'll just wait a second for the demo to come through. Sorry, the poll to come through. I'll just take a look at it. A few people are confused. Some people are feeling great. It's really split. Okay. Let's take that. How, when we add an order, that's up for you to decide, but it's very similar. Cool. Okay, so majority are all right. Okay. Yeah, so a little bit confusing, but not too terrible, which is good. Let's move on, just so we can have a little play it a little bit more, and hopefully as we go along, we will get a little bit more clear with what's going on with this like 2D linked list structure. Let's do, we've done print. So we've done adding songs, adding playlists at the head and the tail, printing, so we've traversed the 2D list. So let's maybe do removing to practice freeing things. And then we'll see if we've got time to do a few of these other fun things like finding a specific song or maybe merging a playlist. So let's grab a diagram, because diagrams are our best friends. And let me make this a little bit neater. I've gotten a little bit messy. And let's delete this. Okay. And let's just add a few songs to each of these. So be song 1, song 2. That's going to point to null. This one's going to have one song, point to null. And this one is going to have song 1, song 2, song 3, and that's going to point to null. So let's say we've got this structure happening here where each playlist has a few songs going on. Start with a very simple case. Our function, we're going to be giving it a song name and a playlist name. So we're going to need to find the playlist, then find the song and remove it, right? So let's say, for example's sake, we're using the playlist name we're going to be given is Chill, and the song we're going to be given is Song 2. This is what we want to remove. So the first thing I'm going to need to do is find the chill playlist in my playlists in Spotify. Luckily, we've already got a function that we wrote earlier that traverses the list of playlists, compares the names, and returns a pointer to the struct playlist that is the one we're looking for. So we can assume that we're going to have a current playlist pointer, or like playlist whatever, that gets returned to us in our remove function. That'll give us the pointer to the playlist containing what we want to remove. So that's already handled for us, which is really great. We're then going to need to traverse the list of songs, and we're going to need to find the song that contains the name of the song we want to remove. In the case of this example here, we will create a current pointer that points to the first song in our list of songs for that playlist. And we will check, is current name equal to the song name of the song we want to remove? And if not, we will move it along, so on and so forth. My question to you is, in this case, current name will equal to song 2 name at this point here, right? Can I just go ahead and call free on song 2 at this point and just remove that? Is this going to work, or is this going to cause some problems in our code? And if so, maybe if you can tell me what the problem is, or maybe how to fix it, or anything, or just a yes or no if there is a problem, let me know. And I'll just pause for a second for the lag to give you a chance. If X was another song, S1 and S3 would disconnect. S1 wouldn't point to null, S3 would be hanging in space with no links. Yeah, lots of things related to it, right? So if I just free S2 and I had another song here, this one would be in space and it would no longer be connected to our list. And another one is song 1 would be pointing to the memory address of song 2, but song 2 doesn't exist. That memory was freed, and we'd get a malloc use after free error if we tried to print the list. So what we need to do is, instead of checking if current is there, we need to check if current next's name is the one we want. So then we can free this and update this pointer here. I see the words previous in the chat. You're exactly right. Instead of checking current next, we can keep a pointer that backtracks just behind. But for example's sake, I'll be consistent with what Henry did in yesterday's lecture and use current next. So we want to write our remove song. So the first thing we're going to need to do is go struct playlist, and we're going to need to find our playlist. And how do I call this function again? It gives the playlist name and the Spotify system. So now that we've gotten the node that we want to remove at, we can go ahead, create our currents, and actually find the song in the list. So it will be struct song, current song, equals to playlist songs. So this is a pointer to the first node in the list. We are gonna wanna have a while loop. While current song next does not equal to null, if string compare current song next name, if that matches the name of the song we want to remove, we want to remove current song next, right? Otherwise, we want to do current song equals to current song next and move that along. Now, there's a little edge case we need to factor in here And if we're going straight to current song next, if we only have one node in our list, it's not going to have a next pointer. So we just need to think about, it's never going to enter the loop, but what if that is the node we want to delete, right? So let's factor in the case of only one node in the list up here. So it'll be something like if current song next equals to null, we want to check if current song is actually the one we want to remove. We want to have playlist songs point to null instead, because we're not going to have anything to point to. Now, just having it point to null is all well and good, and it'll appear fine when we print it. Is this going to cause a little bit of a problem? What am I forgetting to call to actually remove something from a linked list properly? There's one function, and I can see someone's put the word, what about memory leak? Yes, exactly. What about memory leaks? What do I need to call to avoid it? Free, great. So before I lose it, let's free current song. This will work for the very base case. And we can just return here. I might want to like printf song removed. We might actually want to say what song is removed. %s removed from %s, and I should probably do this before I free it so I can actually access the name field. So it'll be current song name playlist name. We can return there. Then if we hit here, let's actually remove it. So we're checking if current song next name, right? So we're checking if like this one's next pointer is the one we want to remove. So we're going to need to, can I like backwards on this? No, I can't, not enough. There we go. Okay. And let's put, so current is here. We want to remove S2. We may or we may not have nodes here. We don't know. We also don't really care. But what we're going to need to do is if current next, so if this node here is the one we want to remove, we're going to need to update the link from that node above it. So before we free the node, we're going to keep track of the node we want to delete. So maybe like to delete. Then we're going to need to update current next to, instead of pointing to S2, we need current next to point to whatever the node we're deleting's next pointer is. Whether that's null or another node, we don't really care. We just want it to point to whatever that is. So we're going to be updating current next to point to delete next. And then once we've updated that pointer, we can free the node. If I freed this node here before I updated the nodes, this node's next pointer, we would run into some problems because we're going to lose the connection. So let's do that. So we know that struct song to delete is going to equal to current song next, right? And then we can let current song next equal to whatever to delete points to. So we want to skip over that node that we want to delete. We can print that we've removed it. We want to remove the song we're deleting, and then we can go ahead and free to delete, and we can just return. Shouldn't line 109 current song, you're exactly right. Thank you for that. Current song is a pointer to a node. It's not the name field itself. Thank you. Okay, so now we've gotten all through this loop and we're at the end here. And we can say we've exited out of our loop for one of two reasons. We've either exited out of our loop because current next is null, or because we couldn't find anything in the list. So in this case, we would have checked everything. So we don't need to do a check for one more node in the list. Just something to think about is to always consider, have I actually looked at every single node in the list that I needed to? So in this case, we're happy to just return, call it, that's what it is. And we should be able to uncomment these now and see if it works. Hopefully it does. I should probably uncomment that so we can see the change. So we're hoping to remove touch and good days from our playlist of favorites. Okay, let's have a look. So we've added a bunch of things. We print our first iteration and we can see that Chill Vibes has 2, K-pop has 3, our one has 4 songs, and we can see that nothing was deleted in the second printing. But I called free. What's going on? I see some things in the chat, some bugs in our code. Why is loop current song next instead of current song? That's so we like free the next one so we can have the connection of the one before. Does anybody have any ideas why this might not be freeing as we wish? Should work, maybe. Double check. I might just add really quickly something to break up this function as well, just so we can see it easily. Okay, let's add something just so it's a little bit more clear to us. So we can see that we're printing the Spotify and then we're calling remove song, but if something is removed, I'm pretty sure we added some like print statements, right? So it's interesting that we're never actually printing them. So our remove code is never actually running, question mark, which is interesting, right? So let's add some debugging. What have we got? Only one node in the list. Current song. Let's just check that we are getting the playlist that we expect, right? Remove song function doesn't have Spotify input. Here. It's got Spotify. So this is commonly going to happen to you in your assignments, and you're going to run into issues and things aren't quite going to work as you expect. So print statements are going to be your best friends, and adding them throughout is everything you're going to need to do. We can see that we are hitting the playlist, which is good. So someone's saying is the first song in the playlist compared? should be, because we have this if statement. Does string compare? I'm going to leave that for the lecture chat. Okay, so we've got that in there. Let's break down a little bit further. So if we're trying to remove touch, we look at this, we're actually trying to remove the first node in our list. So we expect for it to be entering, not for it to be entering here. We want it, because we're not, next is not equal to null, but here we're going straight to current next name. We're not actually checking the first one. So let's do this. See what happens. Now, we're hitting runtime errors. Things aren't quite happening as we expected, but we can see we did remove the first one, which is great. We just need to make sure that we are not entering our while loop if current song, what have we got here? Sorry. Accessing a field via a null pointer, execute. So we're not quite updating our pointers as expected. Do have the solution here next to me. I did want to do some more debugging with you guys, but I am just conscious of the time. So what I will do is I'll copy the correct solution into this file and add some comments about the bugs that we were doing. But I strongly recommend you guys go through, do what I'm doing. We have it removed for the head successfully, but we're going to need to do a little bit more work for the other nodes in the list. So have a play with this code, add your debugging print statements throughout, and then try and find and fix the bugs. I'll update the code on the course website to have the solution for this, and I'll put in comments where the bugs are. So do a little bit of debugging, see how you go. Ask on the forum as well if you have any questions and we can answer it there. But hopefully that gave you a bit of an insight into 2D linked lists as well as multi-file systems. And yeah, thank you for the lecture. Couple things to keep in mind for linked lists for you to read. And yeah, that's all for today. So have a lovely day, everybody, and enjoy your lecture on Monday with Henry. See you, everyone.